As we focus on two-dimensional shapes, we're going to break our conversations into two categories. One about four-sided two-dimensional shapes, and the other about understanding angles. Let's first focus on those four-sided two-dimensional shapes. There are quite a few four-sided two-dimensional shapes. We call those quadrilaterals. And here are the different definitions, or I will say not definitions, but the attributes of these different quadrilaterals. Notice how a parallelogram has opposite sides of equal length, and then opposite sides are parallel with opposite angles of equal measure. But then a rectangle could also be considered a parallelogram, but here we have opposite sides of equal length with opposite sides that are parallel, but we are going to create four right angles. With a rhombus, all sides are going to be of equal length. That doesn't have to be true for a parallelogram or a rectangle. Our opposite sides will be parallel, so that is similar to a parallelogram and a rectangle. And then we have opposite angles of equal measure, just like a parallelogram. And then a square, we have all sides of equal length, similar to a rhombus. Opposite sides are parallel, similar to all of these other shapes. And then we have four right angles, very similar to a rectangle. And then we have that trapezoid, and a trapezoid will have one pair of parallel sides. Now these shapes that I just showed at the top are also quadrilaterals that wouldn't likely fit into any of these different shapes as a parallelogram, rectangle, rhombus, square, or trapezoid. But they are four-sided shapes, and do remember all four-sided shapes are quadrilaterals. Now one of the things that we can do to help students understand different quadrilaterals is we can ask students to create these shapes. Maybe we can use a geoboard, either a digital geoboard or an old school hands-on geoboard, and ask students in this example to create a rhombus and trapezoid on the geoboard below, and then describe the attributes of each. So here students could draw or show a rhombus, and then students could describe the attributes of that rhombus. All sides of equal length, opposite sides are parallel, and opposite angles of equal measure. And then students could draw the trapezoid and describe the trapezoid. There we have one pair of parallel sides. Now besides the geoboard, we can also use other manipulatives to help students explore four-sided two-dimensional shapes. I'm going to show you one of my favorite manipulatives for this right now. All right, one of my favorite hands-on tools for showing different types of quadrilaterals are these angle legs or ang legs. Here I can take these different line segments and construct different shapes. So in our previous example, we made a rhombus and a trapezoid. So in this example, let's make a rectangle. So first I'm going to think about making my rectangle. Maybe I make my rectangle like this. These little line segments are super easy to pin together there. And I've got opposite sides of equal length. All right, that looks really good. Let me just put that on top to make this look consistent. And then with a rectangle, I want to make sure that my interior angles are all 90 degrees. That's where this little protractor can be really helpful. I can place it on top there to show that yes, that angle is 90 degrees, this one, and that one. So there, I made a rectangle. Now let's say I want to make a parallelogram. So maybe I could use some different colored line segments here to make a parallelogram. I like those. Gosh, I've got so many choices here. I'm going to deconstruct what I had made before over with that. So I'm going to go ahead, make a parallelogram. Remember, I have these opposite sides that have the same length. Let's see if I can pin that together there. Sometimes when I'm doing this for people like you there at home, it always takes a little bit longer than I expect. All right. All right, so there we have I have opposite sides of equal length. Now the angles of a parallelogram could all be 90 degrees, but I also could have a parallelogram that kind of slants this way or slants that way. All I want to see is that my opposite angles are of equal measure. So there is a way that I could show a parallelogram, and there is a way that I could show a rectangle. I really like these angle legs, particularly because this protractor is really nice and cute and flexible, so it's really easy for me to also measure the interior angles of these shapes if students are required to do so. All right, I'd like you to push pause now and think about how would you teach students to understand these four-sided two-dimensional shapes in your classroom.